You might have noticed that the sunlight is white. The sun emits all colors of visible light, and in fact emits all frequencies of electromagnetic waves except gamma rays. The color of a light source is related to the color of light that it gives off. Light is a wave, a cycling motion that travels through empty space. When sun emits a light wave, the wave can travel across empty space to the Earth, where we see the sun's light. Light waves, like waves in water, can be described by the distance between two successive peaks of the wave, a length known as the wavelength. It is usually characterized by the Greek symbol lambda. Different wavelengths of light appear to our eyes as different colors. Visible light is the light that we can see, and thus is the only light detectable by the human eye. Visible light is usually defined as having wavelengths in the range of 400 to 700 nanometers, and it contains all the colors from violet to red. There are different colors of light that correspond with narrow wavelength bands. These are clean spectral colors, namely VIBGYOR. The abbreviation of VIBGYOR is violet, indigo, blue, green, yellow, orange, and red. When we mix these colors, we just get one light called white light. In this video, we try to learn about light dispersion. Visible light, also known as white light, consists of a collection of component colors. The separation of visible light into its different colors is known as dispersion. These colors are often observed as light passes through a triangular prism. Newton was the first to make this experiment by transmitting light through a prism. He let the sunlight pass through the prism expecting to see the white light on the screen set to one side, but instead, he saw the spectrum of light after the scattering. He was a little skeptical about the importance here, but decided to do something here to confirm it. By controlling the intensity of the incoming light, he allowed only one color to pass through the prism. Apparently, the ray of light was refracted and didn't undergo any further dispersion. Therefore, he noticed that different colors of the spectrum of light bend differently as they have different wavelengths. Prism does dispersion of light because the light of different colors has different wavelengths that are refracted or deviated to different extents. Let us understand the cause of dispersion in detail. When white light like sunlight travels through air or vacuum, all the colors of light travel at the same speed. But when these colors of light enter a dispersive medium like a prism, their speed changes. This is because the refractive index of a medium depends on the wavelength of light passing through it. The value of the refractive index of the material of prism is lesser for the light with a higher wavelength, like red, than the light with a lower wavelength, like violet. The higher the refractive index of a lens material, the slower the light will travel through it. In reality, the refractive index of any material varies slightly as a function of the wavelength. This means that various colors of light will each actually have a slightly different refractive index in the same prism material. This phenomenon is responsible for chromatic dispersion, or the breaking up of white light into its component colors by prisms. So, the material of the prism is more optically denser for the light of violet color than for the light of red color. Hence, the violet-colored light has a lesser speed than the red-colored light. Due to this reason, the violet light bends the most, and the red light bends the least while passing through a prism. Newton experimented on the recombination of the spectrum of colors to form white light. Let us understand this experiment in detail. Newton passed sunlight through a glass prism and obtained the visible spectrum. Then, he tried to split further the colors obtained from a glass prism by using another similar glass prism, but he could not get any more colors. So, he passed the beam of sunlight dispersed through a glass prism through another identical glass prism that was held alongside but in the opposite direction. In this arrangement, the first glass prism placed on its base disperses the white light into 7 colors. In contrast, the second glass prism placed on its apex receives the 7 colors of the light and recombines them into the white light. Here, the refracting surfaces of the second glass prism are in the opposite direction to the refracting surfaces of the first glass prism. So, the second glass prism is able to recombine the spectrum of colors, as the angular dispersion produced by it is equal and opposite to the angular dispersion produced by the first glass prism. It is to be noted that the incident white light and the emergent white light may or may not be in the same direction. The inference of this experiment helped Newton conclude that the sunlight is made up of 7 colors. Such a crucial observation forms the basis of our understanding of various natural phenomena occurring in nature. One such natural phenomenon of light dispersion is a rainbow. We all seen the rainbows in the nature. Rainbows appear in the part of the sky opposite the sun, usually in the early morning or late afternoon. How do this rainbow form? This we will discuss in the next video. To see more videos like this, and please consider subscribing.